Alright, so we were given this information. Paco lives in Pichaburi, which is 762 kilometers away from his friend Pachita. Find the circumference of the Earth. Additionally, we also know that on June 24th of every year, Paco will observe the sun right over himself. And on the same date, this shadow Pachita owns, which is 24 meters in height, would cast a shadow of 2.85 meters. Now let's map it in a better way. Alright, this is a not-to-scale model of the sun and the Earth. Now first, let's establish that the sun ray shines in a parallel manner. The reason I can say this is because in real life, the sun is so much bigger than the Earth, and is so far away that it is not actually mathematically significant if it is slightly to the side or something. Anyways, Paco must be here from the passage, because the sun is right on top of his head. And up north, 762 kilometers, his friend got a tower. And the tower, oh my gosh, the tower cast a shadow of 2 meters. So boom, 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 this is the sun ray. 2 meters right here. Now, let's mark the center of the Earth. Now, how do we find the center of the how do we find the circumference of the circle? From this, what we can do is, first of all, we can draw a line from the straight tower I drew to the center of the Earth, and do the same thing for Pachita or Paco. And now we have a piece of the Earth carved out, and we know that the edge of this piece is 762 meters just from looking at this. And we notice that we have like a pizza situation, that if we know all the pieces that we can carve out and multiply it by this number, we would cover the circumference of the Earth. And so how do we find how many pieces there are? We can do it because we know that this is 360 by definition of circle. If we can find how much one piece is worth in terms of angles, we can find how many pieces there are. So how do we find it? If we notice how the sun ray works, it is always parallel. And this line from the tower through the center is a transversal line cutting through two parallel lines, which means that this angle and that angle is an alternate interior angle. And by the alternate interior angle theorem, these two are the same. So now we can actually find this, and I will show you how to do so. This is a model of the tower and its shadow. So that's the tower and that's the shadow, 24 meters and 2.85. So this angle that we're trying to find would be over here. So this would be the angle we're trying to find. How can we do that? Well, grab a protractor and measure it. It is around 6 to 7. No, I did it wrong. Yeah, it's like 6 to 7. But if we want to be exact, we can also do the inverse tangent of 2.85. This is not how we did it in class, but by definition of the tangent function or the inverse tangent function, it should spit out this angle. But the way Eratosthenes do it and the way we did it in class was literally draw the graph or graph it out and measure it. So to be really exact, I'm just going to use this, and it rounds to around this number. Yeah, so like this. I drew a line down, assume it's a straight line through the tower, and it sort of created an angle with the sun ray, like that. And let's draw Paco's line all the way through. By the way, this is also a line parallel to the sun ray. And so it creates a transversal line like so, that cuts through two parallel lines. So here would be alternate interior angle, and so they're actually words the same. We just measured the angle of that angle using this, and so this should be, by alternate interior angle theorem, the same angle. So around the circle is 360, and we should divide that by 6, 7, 2, and 6. So now we do know how many pieces of this there are, and each piece is worth 762, so we can just multiply that. And this should spit out the circumference of the Earth in kilometers. Alright, so what I did, this equates to around 52 something. So there are like 52 pieces and each piece is like worth 762. And so we can just multiply 762 by that number, which gave me this 40,507.02 kilometers, which is not so far away from the real distance.